By expressing 1 in polar form and using Demois's theorem, find the solutions to z cubed equals 1 in polar form. So z cubed is equal to 1, and 1, if we look at it on an argon diagram, is just here. So that's cis 0 as the principal argument, but in general cis 2n pi. So every time we arrive back at this point, no matter how many times we go around, in what direction. So we can say that cis 2n pi, where n is an integer. So if we look at z, using Demois's theorem, that's going to be cis 2n pi divided by 3 for n belonging to z. So if we take n equal to -1, we're going to get z is equal to cis -2 pi by 3. If we take n equals 0, we'll get z is equal to cis 0. And if we take n is equal to 1, we get z is cis 2 pi by 3. So we get 3 solutions in polar form. We want to convert the roots into exact Cartesian form. Well, this first one here is cos -2 pi by 3 plus I sine -2 pi by 3. And remember that -2 pi by 3 is down here. It's actually -120 degrees. So this is 60 degrees, and we know that cos 60 is a half, and sine 60 is √3/2. Then think about where it is. So that's actually going to be -1/2, take away I √3/2. Now, cis 0 is more obviously just 1. And then if we do cos 2 pi by 3 plus I sine 2 pi by 3, that's going to be up here. And these same things apply, because this is 120 degrees and this is 60 degrees. So that's going to be -1/2 plus I √3/2. What is the sum of the 3 roots? So if we do -1/2, take away I √3/2, add 1, add -1/2 plus I √3/2, then we can see we've got -1/2, add 1, take away 1/2, so that's 0, and the imaginary parts also cancel, so it's going to give us 0. Now that's actually to be expected, because if we look at these 3 roots and the symmetry here and think of them as vectors, if we added these vectors, we'd expect to get 0. Display the roots on the grid below. So the first thing we notice is that they all have a modulus of 1, so they're going to lie on the circle of radius 1. Now the first one is cis 0, so that's going to be just here. The next one is cis -2 pi by 3. Actually, the order doesn't matter. I'm saying the first one and the second one. That's the first one I'm plotting and the second one I'm plotting. So this one here is going to be like so. So there's the point and there's the vector. And then finally we're going to put on cis 2 pi by 3, which is just here. like so. Now once again, because this is important, look at the symmetry of the distribution. Not only that, we know there are 2 pi radians in a circle, we have 3 solutions, and these are separated by 2 pi by 3.